Yeah, hi, this is Sinu Rathod. I have completed this project like behavior detection of AI stored in ASP. So I wanted to I want to discuss this project in detail. In detail. So let's dive into it. First of all, I wrote this business problem like the application or use cases of this project and the solution like problem and solution like solution using this machine learning and deep learning or like CNN. We are like taking the leverage of this the deep learning and CNN. We are able to capture the behavior of any person or any person. So and then like next I just wrote the technical stack that I used in this project like the Python I use and deep learning CNN and the pre-trained model using the VG16 16 pre-trained model like which is already trained on which data set like I'm using taking the leverage of that VG16 particular model and I'm importing the required libraries like NumPy for the numerical calculation and Matplotlib for the the graphical like visualization purpose and TensorFlow. These are deep learning the frameworks of the libraries and here the sequential sequential model for the stack stacking the number of the hidden node and like number of the layer and here the dense layer dropout layer flatten to convert the multiple dimension into the single dimension and the batch normalization into convolution 2D max pooling to reduce the size of the image dimension of the image you can say the application sorry this like, the VG16 model I'm going to be using in this particular project to to accomplish this project. I'm using this VG16 model. I'm training this model on my image dataset and again we are importing this the optimizer Adam optimizer I'm going to be using to update the weights to reduce the error and here the image generator I'm importing the image and Keras from Keras I'm using this image generator to generate the images diversity of the image diversity of the images means to increase the number of the image I'm going to be using this image generator and early stopping and model checkpoint this model will help us to train. We are working with a huge amount of the data set like large amount of the data set using this model checkpoint and early stop what we do means if our model the model is improving then like validation accuracy and training accuracy only gonna if improving this then only we're gonna be we are allowing our model to train on the dataset, or else like we are saying our model to stop over there only. So for that we're gonna be using this early stopping and model checkpoint and mixed precision training for speed up to speed up our training time. We're gonna be using this mixed precision library and here I wrote the code about like if our system contains the GPU, then take the leverage of like the GPU and train the model. If we do not do so, like it will take if we are working with a huge amount of the data set, it will take a lot of time. Using the CPU can train, but it will take a lot of time. So I'm writing the code to use the GPU and GPU growth. Like if we in our system, if we have two or more GPU, then like utilize those all the GPU. To utilize those all GPU, I'm going to be using this the code and here the image generator. Like I'm using for two. Now image generator is basically like it is a data augmentation technique where we wanted to improve the data like the number of the images. For that in diversity of the images, I'm using this this image like the data augmentation technique and splitting the data set into the training and the validation. From 10% for the validation and 90% for the training. And these are the techniques like to improve my like increase my the images. I'm using technique like a rotation, width shift range, shifting like a height shift range, shear range, and zoom range and zooming and zooming the image randomly. I'm zooming and increasing my images. Fill mode. I'm filling this like horizontal flip, vertical flip, and the brightness. I'm increasing the brightness of the like image, and again and those images I'm saying to they increase the size of the data set. So again I'm here importing the path of my and the data on my data set, and here I'm mentioning the batch size like a 64 like batch wise the model is gonna train. So for that like I'm mentioning the variable in the batch and batch size, and here on the training data set like directory training. I'm giving the training data set training variable inside that. I'm saying that this many of amount of the data the image should be in the training, and this many amount of the images in the testing of the size 22 424 and the batch size is 64. We already mentioned there like declared there subset is the we have this data is this data. This is the validation data that we are saying. Class mode is like if we know that our target variable is a categorical data type, so that is like to convert that categorical our model like model will not accept the categorical, so we need to convert that categorical into the numerical. For that we are like we are using this parameter, okay, categorical. The class mode is equals to categorical, and then we are printing like I'm printing the and the indices means like the indices mean the target variable contain the number of the categories, like number of the instances. Like there are image emotion, we are working with the emotion detection, like in behavior detection there are different kind of the emotions, like in different categories, like in angry, sad, and fear, happy. There are total seven classes are there. Seven classes are there, and we are working with the total seven emotions, and here plotting some sample images, like in the data set, training data set, in the training we are trying to plot the samples, like total nine samples we are printing. These are more the samples. And next what we are doing is like we are working with, as we know, we are working with a large data set, like large images, or working with large images. So to train our model faster, we need to use some technique to where I think get the images to get the image the batch wise. If we put those images in the cache memory, then it will be the model, the accessing will be happens faster. So that is why we are using the shuffling and prefetching and the catching. But actually, like I haven't commented this action because I haven't used we can able to use that one as well. And here finally we are building the, I'm building the VJ16 model. Importing this, the lambda for to convert that our image contain 0 to 5 total, like the intensity value. 0 means total black, and 255 means totally white image. So from 0 to 255 in the range of our images, we converting that into the 0 and 1 format. Like we are converting this, we are converting into the array, 0 and 1 format, lambda layer scale pixel value to 0 and 1. We are scaling the the images to 0 and 1. We are freezing the top layers, because we are working on simple data set, and the model which is already trained on the large data set, we are working this model for simple data set. We are keeping some top layer, top layer. We don't want to train top layer, we just from want to train we just want to train on the bottom layer only. That is why we are freezing some top layer. And sequential and lambda, we already talked about this VJ16 model. Upon that, flattening the output VJ16 only, and we are trying to flatten image where our images is in a three-dimensional, like image is the three-dimensional image, or two-dimensional we were working with here. Batch normalization dropout and the dense. Okay, here dense layer with containing the 4,996. So neuron, and we are using the activation function, non activation function, and the batch normalization. For batch normalization, normalize the inputs, and normalize the input, and those input we are pushing or feeding to the next dense layer. Here again we are using the next dense layer, 248. The neurons, we are using an activation function. We want to be using radio activation function again, the batch normalization and dropout, for to prevent the overfitting our model. And here again we are using the same, and finally we are using these are the like output layer where we are using giving total seven classes. So, and we are using softmax application, softmax activation function to get the output in the form of the probability, and combining our model optimization. We are using this Adam optimization loss. We are using this in the categorical percent. Okay, and matrix is accuracy. And this is printing, and again we got this one. Okay, after defining the structure of our model, finally we have to train our model. So model checkpoint and all this topic we want to be using over here into to save the best model. If our model the accuracy of our training accuracy and the validation accuracy, in both are the increasing on the parallelly, then only we are we're gonna be we want to save our model. That is why we're gonna be using this model checkpoint and all stopping. And here the parameter, we are seeing the dot keras format, and the monitor, we want to monitor the validation accuracy. The validation accuracy is increasing, then only we want to save our model. Verbose means like it will use the information. It will it will use okay, verbose ensure the detail. It will give the detailed information about the result. And SEO based only, we are saying SEO model based on SEO based model only. And the weight also we want to save or not, like we are giving the false. And then early stopping, if the monitoring the validation accuracy, and the patient still like 20, if the validation accuracy not increasing also, we are saying that like keep running the epoch. And the verbose, it will give the information about the result, and mode is equal to auto mode. Finally, we are fitting the model on the training and the validation data set, and the epoch we are giving the 100 epochs to get the great accuracy, good accuracy. Batch size we are using 65, 64 batches in the callback checkpoint, and all this topic we are using. And finally, we are training our model. And this is after early stopping, because our training validation accuracy is not increasing and improving. Till 46 it was improved 58% accuracy, and the validation accuracy and the training accuracy is 71%. So let's like we are I'm plotting the accuracy of the training of the validation accuracy. Here is the, you can see like our model, as and how our epoch increases the training accuracy till 49. We have seen the accuracy is 70% increased, but when it comes to this validation accuracy, it's only like around the 49 60 percent accuracy we got on the validation data set. And here we can see the loss as well. And after we saved our best model, like I'm loading that model over here, and testing that model on new unseen image, and checking the result, like is it correctly predicting or not. Okay, thank you. This is all about my project. Okay, bye bye.